This video explains my little adventure with this scope. Is the oscilloscope Heathkit O-10, and this oscilloscope is from the 1966 or something like that. It's using tubes. As you could see, I think it has 11 tubes or so, or something like that. And the only thing I did up to now is to change this tube. Also, the scope is more or less working. It's not perfect, but it's just a small video about this one. Okay. Basically, this scope have this switch and the intensity knob. Focus, the vertical position, horizontal position, the vertical gain, horizontal gain, the frequency selector and the frequency vernier, and the sync amplitude, okay, and the sync selector, and the input from X1 to X100 and the phase, okay. Here it generates 1 volt peak signal just to use for some kind of testing, something like that. And this is the vertical input and the horizontal input, something really very simple. And something I found quite useful was to get the original manual. This Heathkit is a kind of kit, or just not a kind. It's a kit that you were able to buy and connect all the parts, and this manual explains you how to do that. Okay, so what I did was I just started analyzing the schematic. Okay, and here is the schematic, you see, and it's a bit difficult to identify here the different parts of the scope, although it is a very simple scope. Okay, but I found in the internet something more useful. That was this other design, this other schematic. I will just put it in the link to this one. Okay, so you could see the different parts, although it is in French, you could perfectly understand. This is the part of the tube of the CRT, and the power supply part. Okay, this also is a power supply part, and these other parts are okay. So let me show you more in detail. Okay, so basically this part is the here you get the power, and you have a transformer here, and you get different voltages. This is just a diode, the diode tube, and from here you could get the voltage minus 1200 volts. So take care with the voltages that you are getting inside here. And here you have 2 big capacitors that regulate this voltage, and you could use that for the electromagnetic field of the tube or the CRT. And there are some other parts here. You get a regulation to get 340 volts and 300 volts. Okay, and also from this other one you could get a kind of synchronization signal, and this 1 volt peak that I explained you is not peak, it's 1 volt and sinusoidal signal. Okay, from these volts, these 340 volts and 340 volts, you get, okay, through here and to here, you get different voltages. Okay, so here you get 110 volts, 115, 80 volts, 100 volts, and 130 volts. Okay, and you send this voltage to different parts of the circuit. Okay, So other parts that you have here are the horizontal amplifier. Okay, this is the horizontal amplifier, and this long one is the vertical amplifier. Okay, this one is the vertical amplifier. So you have the vertical input here, and from here you could choose 1x, 10x, 100x, and it just amplifies it through different phases. Okay, and then what you get is the voltage for the top plate and the bottom plate for the vertical amplifier, sorry, and for these other plates from the horizontal amplifier. Okay, so you could deviate the beam that comes from the back of the tube. Okay, about the horizontal amplifier, what you have is the time-based generation here. Okay, you could choose different, it is not shown here, but you could get different frequencies, and here you have the vernier to adapt the potentiometer here. And from here you get the blanking circuit that just clear the signal when it is coming back. Okay, so basically it's not complex circuit, and based on this, what I did is to create my own simulation. Okay, so I used a very interesting simulator that is LTSpice. Okay, and I have another video about this LTSpice. Okay, and let me show you what I did here. Okay, so what you could get here, more or less, you see it, is the same simulation. Okay, so you have here the control part, the CRT part, sorry. What I did instead of a transformer is to use different voltage generators. Okay, so it's like the output of the transformer, and I get exactly the same, the power supply, but I joined the two parts of the power supply, so the one that generates the 340 volts and 300 volts, and the rest of them. Okay, so the 180, 110, and so on, and the generator of the 1 volt CC that comes here. Okay, and these kind of round things are something that you have a knob at the front of the oscilloscope. I will give you the link to this one also at the bottom of the video in YouTube. Okay, so you have the power supply here, the horizontal amplifier, so it's the same, but you get a simulation. You could simulate all this and change all the things. The blanking circuit and all the time-based circuit, and here the vertical amplifier. Okay, so you could get all this part. In this circuit I connected the 1 volt CC to the input, so I could simulate with some input inside. Okay, so when I run the simulation, what I get is really this kind of graphs. Okay, so for example, if I say, okay, the 1 volt peak, or the 1 volt, sorry, the 1 volt, I get this one. Okay, if I say, okay, I want to see what I am getting in different parts of the circuit. For example, I want to see what I am getting at this point. Okay, so what I get at this point is this signal that is affected by this capacitor. Okay, and here is where I suppose after this filter I get here regulated voltage. Okay, the difference between this and this is really nothing, although it seems to be very variable. Really, it's not so variable. Okay, so you could have from here you have about 1 kilovolt, so here you have the signal more or less regulated. Okay, it's quite regulated, and here you have this intensity knob that we will access this knob to access this point to see what is the voltage here. Okay. These other potentiometers that you have here, or variable resistors that do not have this round circuit around, because they are inside of the oscilloscope and not accessible from outside. Okay. So also what we will see is in the time base, I would like to see what I generate for the horizontal amplifier. Okay, so if I click here, I see this. Let me show you something like this. Okay, I will zoom here. Okay, more or less is this what you get is about 43 volts, something like that, and this is the time base. Okay, it's a sawtooth signal that allows the signal to go to in the horizontal way. Okay, I will not go through the details. If you know more or less details about how a oscilloscope is working, you will understand why this signal is necessary. It's just to ensure that you go to the signal goes to the right and then to the left again. So when it is drawing or showing the signal in the oscilloscope, it will come back every time it comes here. So when it comes back, in order to prevent the beam to show the line coming back, you have this blanking circuit. Okay, so you have this K, and if you click this K, what you get is this one. Okay, so let me show you. It's just this kind of peak, and what you get in this moment is from minus about 900 volts, you get something low, different voltage. So you prevent here, let me show you here, this is the K, so you prevent the beam coming through here. Okay, so it's like a block. In the moment the oscilloscope is showing the signal and is going to come back, it just block that and come back not showing anything. Okay, so this is you see, this is the kind of signal that generates the blanking. We will see this blanking later. Okay, so with this simulation I came to the oscilloscope, and the first thing I did, I think it's quite important, and is why I recommend buying or getting the manual from wherever, is because in the manual you have a part that explains how to adjust the oscilloscope. Okay, so I will just show you more or less what is here. Okay, so you have to do some kind of calibration with the oscilloscope, and everything is shown here in this manual. Okay, so you have all the details here on what you have to do. Okay, and then you could just go to the next page and continue doing what is explained in this manual. So I recommend you to get this manual. You could get it from the original manufacturer that you still is there. Okay, and there is also a very interesting section, this one, operation of the oscilloscope, that explain all the knobs on the oscilloscope, what they do, and what you could do with all of them. Okay, to control your oscilloscope. This is also a simple oscilloscope. It's nice, and I could imagine that in that times having this kind of kit would be something really interesting to get. Okay, so everything is explained here. It's really something I just recommend. You have a lot of details here, and you have even a list of components and some things. What you do not have here in this manual is an explanation on how it works internally. Okay, there is nothing about that, but for all the parts it's interesting that you could have like all the components of the oscilloscope here, and if you want to replace any component, you could get like the full list of of components in this manual. Okay, so you could find it from the original manufacturer. As you could see here, it's from 1954. Okay, so let's come back again to the oscilloscope. Okay, first thing is that, as I showed you, there are like several points with more than 1000 volts. So how are you going to measure that with a normal oscilloscope? Okay, definitely you need X100 proof. Okay, this X100 proof, you could just use in your oscilloscope the correct X100, okay, and using that position. So I'm going to have a division for 500 volts here. I don't know if you could see it properly. Okay, 500 volts. So the line from one line here to this line here, there are 500 volts. Okay, so this is 0 minus 5 minus 1000 minus 1500. So you will see there, and positive. Okay, so this is the way I'm going to show you how to run this oscilloscope more or less. So let's start using these gloves, of course, that are an important element that you could sorry for the camera moving around. This kind of equipment sometimes is difficult to manage. Okay, so let me put on the gloves, and in the meantime you could see the inside of the oscilloscope. And after putting on the gloves, I could just using the proof. Okay, I use this one because I want to prevent it touching anything. So the ground is this one. Okay, let me show you some things. I will just leave it here. First thing is that I will try to switch it on. Okay, I will switch it on, and see this connected to this 1 volt. I will show you how to show the signal. Okay, let me see if I could show you this thing working. Okay, it is working now. Okay, this align correct. Okay, vertical position. Okay, so more or less is working there. You see, it's not perfect. It's moving up and down, and until it hits up, it will do things like that. So it is a signal that is about between 10 to 100 Hz, something like 40 Hz or something like that. Okay, so what I am going to do with that, first of all, I will show you the part that I mentioned here, that generates the 1000, more than 1000 volts. That is this part. Okay, so I will show you this point. Okay, so this point here, this potentiometer is the one that control the intensity. Okay, you have to take a lot of care with this scope, because this one is this one. Okay, you see intensity. So at the back of this one, you have more than 1000 volts here. Okay, so take a lot of care. So where I'm going to touch this one? Okay, well, just let me show you. Okay, this one, the red one. Okay, so if I touch this one, let me show you what I get here is what I mentioned you about 1000 volts with some noise there, or some things that maybe it's because I'm not touching properly. Okay, see, but it's about less than 1000, minus 1000 volts. Okay, so this is the first thing I wanted to show you. The other thing I wanted to show you was, okay, about this this blanking that you have here. And this blanking is, as you could see here, it's about minus 7,700 volts. Okay, so how am I going to show you that? Okay, that part, the blanking, is as I mentioned here. The blanking is done here. Okay, but as it is difficult to find this specific component, that I think I found it, but it's difficult to find it exactly in the map. So I went to the back of the oscilloscope to find this K point that is the blanking signal. Okay, so let me show you. I think that this component is really this capacitor. I don't know if you see that. This capacitor and this resistor are these, sorry for moving around, that I think they are, let me see, no, not here. Let me show you exactly where is this here. I think they are this capacitor and this resistor, okay? Because the resistor I showed you is 100K, and this capacitor I do not see it, but maybe this is this one. Anyway, I will go to the back of the oscilloscope. Let me show you. Okay, I will try to turn the oscilloscope. Okay. So take care what you touch with this oscilloscope, because it is really dangerous. Okay. Okay, so here I have the back, and the point exactly where I have this this signal, this blanking signal, is here. Okay, this resistor. Okay, here. So here, let me see if I could show you with more detail. Okay. Okay. So this one, you see the resistor there, the brown cable coming from here to the resistor, and then the resistor coming to this point. Okay. And really the blanking is coming through this red cable. Okay. So if I connect there, I have to connect it first here, and then connect it there. Let me show you. Okay, when I do that, what I get, let me try to show you that. Okay, so you now see the oscilloscope. Let me show you that. It's not so easy. Okay, so you have there that, and I will move it up. Okay. So I will use a different divider. All these peaks you see are because I'm not touching it properly. Okay. Okay. Okay, so what I get here, okay, is this one. You see? Okay. Don't forget about these things. The thing is that you get this signal. You see, I'm trying to amplify it. And that is very similar to the one I showed you. Okay? So you have that one. You see it? Okay. So that one is really very similar to this one. Okay, the other one I wanted to show you is really the last one. Is the part for the generation of the of the time base. Okay, so it is generated here, and it is really generated through these two cables. Okay, so these two connections to the amplifier, the horizontal amplifier, or it goes to the blanking, because the blanking is generated based on this. Okay, so where could I find this thing? Really, in the knob that controls these frequencies. Okay, so that knob, let me see if I could show you. This knob is somewhere like okay, somewhere like here. Let me show you. Okay, this knob is the one that you have to pay attention to. Okay, so where in this knob I'm going to do that. Let me give more light to the knob. Okay, now I have more light. Okay, let me show exactly where I will connect it. It will be to let me see. Okay, this point could be, oof, you're not seeing anything, sorry, to this point. Okay, this one or this one, because both are connected through this disc. Okay, so this one or this one cable comes through here. Okay, so connected to that one, and I will show you what I get. And the oscilloscope, the first thing I will show you is that here when I simulated let me show you the part where this thing is simulated. Okay, here it is. When I connected this one, okay, what I get is, okay, let me zoom out this one. Okay, you see? So this is what I get, this sawtooth, and it depends on how I change the frequency vernier and this selection, I will get different values. Okay, so this is important, and it comes from about 42 to 44 volts, something like that. Okay, so let me show you that, and I will connect there the negative. I will connect it to the chassis and the other to that part, and in the meantime I will show you the scope. Okay, so you could see what you get in the scope. Okay, now you get the scope there, and okay, let me try to show you what I do here. So the first thing is to choose something like 20 volts or something like that, because it's going to be 40, and come back with this one to the 0 position. Okay, so I put it in the 0 position. Okay, here I have it, and okay, okay, 25 milliseconds. The distance from here to here, we will see. Okay, so I will connect it. I will change this one to this one. Okay, and I will connect it, and we will see what we get. Okay, so I connect it there. Okay, connected. So you could see that, let me see if I could put the Okay, the trigger and the frequency. I'm changing the frequency. Okay, so now you could see that this is the sawtooth signal. Okay, and now the okay, channel 1 is 10 volts, so 10-20 volts, about 20 volts. So the simulation is not exact. You see the simulation, I got something like 40 volts, but it is okay, but this is the zero. So this is 10, 20, 30, 40, 50. So yeah, it's correct. And this is the this is what you get, the signal, as I mentioned. Okay, so more or less this is what I wanted to show you. I found some things that are a bit strange that I will check in other moments, like this tube I changed. This tube, let me switch off the scope. The thing is, when you switch off the scope, you do not get voltage anywhere. Okay, so I don't think you have to be worried about that. What I found is these two capacitors, these two big capacitors, are the big capacitors that I mentioned you here. Let me show you just a second. Here, okay, these two capacitors are those that I showed you. Okay, you see, minus 1200. So and this is the tube that I changed. Okay, so what I have here is that this is the tube I changed, and the thing is that those capacitors that are there, these two are those big capacitors. This one gets quite hot, and I don't know why, from time to time. And when it gets hot, this tube start getting like a lot of light. So I'm not sure if it's a problem of the capacitor or a problem of the regulator. So of the transformer, that is this one. So probably next step I will change these capacitors and see what happens, if it continues or not. It seems it is working quite well and producing the mentioned voltage, but I don't know, something is wrong there. Okay. Okay, and that's all for this scope. Okay, I hope you enjoyed this video. Thanks for watching. Bye.